Another helpful application of these formulas is being able to compare different interest rates that you are offered. So, if you were offered an interest rate of 3% compounded annually, is that better or worse than a rate of 3.2% compounded monthly, right? So, to be able to compare, you have to kind of change them into the same system. So the effective rate of return is basically what interest rate would equal if it had been compounded yearly. So not changing it into a simple interest because that doesn't make sense, or maybe just simple interest for a year is the same, but compounded just annually or yearly. So first of all, the effective interest rate, that's the rate effective, is take everything in those parentheses, 1 plus r over n, and raise it to the nth power, and then subtract 1. Okay, so in other words, this is like the rate that you're getting, but with the 1, that's taking into account the principal as well. So this is going to give you a decimal, which you can turn into a percent. Now, that formula is for compounded n times per year. Okay, and you actually need a slightly different formula if it's compounded continuously, and that is just the e raised to the n, sorry, to the r, e raised to the r minus 1. Sorry, I got confused because this was an n and this is an r, so it's good to kind of note that. Obviously, if it's compounded continuously, there isn't an n, so that wouldn't make sense. So if it's, of course, r, and let me erase that and write a better r for you while we're at it. R. This is for compounded continuously. This will convert it into just compounded once annually. Continuously. Okay. All right. So for example, what is the effective rate of return for 6% interest compounded monthly versus compounded continuously? So, is it better to have your interest compounded monthly or compounded continuously? You probably feel like you saw enough examples that you would pick continuously would be better, but like by how much, right? Just a tiny bit, but what exactly, how much is it? So let's do that. So our monthly means that n is equal to 12, and our rate is 0.06. Okay, so it's a 6% interest rate, but what if it was only compounded yearly? How much interest would they have to give you for that to be the same amount? So RE is equal to 1 plus 0.06 divided by 12 raised to the 12th power minus 1. Okay, so type that all in. So this is our interest rate that we have compounded monthly, and then subtract the 1 and you'll get 0.0617. Okay, so about in percent, 6.17%. Okay, if this rate was compounded yearly, you would have to get 6.17% versus compounded monthly 6%. Okay, for compounded continuously, the effective rate is e to the 0.06 minus 1. Okay, type that in and you get 0.0618. So that's about 6.18%. 8%. So as we suspected, you get a little bit more if you're compounding continuously, but now you can see exactly how much more, 1/100%.